Says this hangout on there is live. I'm live. It's early in the morning. I'm tired. I'm gonna try to get this one off. So this video, or the intent of this video, is to discuss my journey of learning to program within Elm, which is a programming language focused on web application development that abstracts away JavaScript, so that you are basically building maintainable applications. That's the short of it. And so this video is primarily focused on me basically introducing quote unquote dependency injection into this web application that I've been working on, that we've been working on, the Lambda cartel. So dependency injection, that term is just, it's been butchered. You see it on job descriptions, and when you have technical phone screens or interviews, people that have no clue what it is they like to ask you that question, what's your experience with that, and they tightly couple it to an IOC container, which I'm not sure why people believe that an IOC container has to come with or has to partner dependency injection, but mainstream, they're entitled to their belief system. Anyway, all right, that was me venting. Anyway, so what is dependency injection as I understand? Why is it beneficial, right? Oh, I wrote a blog post yesterday called Dependency Injection and something else. And I'll probably share my screen and show you the blog post, because more than likely I'm going to embed this video in that blog post. Dependency injection, as I understand, is a technique to basically swap out dependencies at runtime so that you can basically test the application, so that you can have the capability to test the application without having the dependencies that the production environment requires. Or within the production environment, you have the dependencies that are required by that environment. That's the way I would explain it. So why is this beneficial? Well, as I attempted to state earlier, software is typically, currently when we're building software, we deploy software within different environments so that each environment up into the last environment can actually qualify that software to the next level, to see if it's ready for the next level. Ultimately, we want to get it into production. So in my case, when I make it a practice that when I'm building software, I'm all about like correctness, right? And so with that said, I usually set up my applications so that I can run them, so that I can have the option to run them in complete isolation if I choose to. And this helps me troubleshoot business logic issues, domain issues, right? Or instead of running it in complete isolation, I can run this application basically in integration mode, where it's actually touching or relying on external systems, the web server, a database somewhere out there, etc. So the advantage is basically, for me, with dependency injection, quote unquote, is it supports my test automation requirements for the way that I professionally build systems for paying clients. So now that I attempted to give a dissertation on dependency injection, I'm now going to discuss how I implemented that in Elm. Okay, so share my screen. Come here. Share my screen. Present to everyone. Yeah. All right, so I have this blog post right here. Oh, where you at? I have this blog post right here. And it says Elm dependency. I hope I spelled this right. Injection and functional programming. And I'm going to take this video, and if I don't screw it up, I'm going to embed it right in here somewhere. So this is somewhat commentary to this blog post that I have. Else, if I do screw up this video, I'm just going to delete it and maybe attempt it again. So when discussing dependency injection, which I think is more of a object-oriented term, one can argue that it's not, but I think it stems from object-oriented programming because that tends to be mainstream. When we're talking about it, it's done differently, or at least the technique that I've used is different from the mainstream way of supporting dependency injection or writing dependency injection into your software. So within object-oriented, you can introduce or quote unquote inject dependencies through a constructor of a class, or you can rely on quote unquote IOC container, which is, if you ask me, this is me being cynical, is basically people that want to sound really smart, and instead of saying dictionary, they say IOC container. Well, as far as I'm concerned, it's a dictionary object that may have some additional behavior. It's a dictionary. It's a list of key value pairs. I'm not sure if it's a list. It's maybe an array of key value pairs. Anyway, it's a collection of key value pairs in which the key is the, more than likely, at least the way that I've been building and what I've seen, the key is the interface that you pass in which you provide the type of interface, and the value is the instance of that interface, right? Meaning the class, the instance of a class that implements that interface. So that's the key value pair. That's the way it's set up. It's a dictionary, but people want to be complicated and they want to call it an IOC container because they want to sound really smart. Anyway, all right, I'm done venting. I guess there's times I want to sound smart too, but I'm trying to calm that down. Anyway, so I just discussed how dependency injection usually is implemented in object-oriented programming. Within functional programming, I have found that it's done a little bit different, right? So instead of injecting your dependencies through the constructor of a class or using a glorified dictionary, aka IOC container, glorified dictionary, we within functional programming, an approach that I'm aware of is, well, we basically take a function and we take the signature of that function and we basically use that signature to serve as our interface for other functions to sit behind it. How can I say that a different way? Because I know what I said, but I know I didn't express it the way that most people would appreciate or can understand, because I don't think I expressed it the right way. All right, so I'm going to start over. All right. So within functional programming, aka FP, a technique that I think I understand, or at least that I'm aware of, is that we can basically, in order to do dependency injection, we create a type that represents a function, right? And with this type that we declare that represents a function, the way that we declare that type is by establishing the signature of that function. All right, I think that's a little bit better. So, for example, this is Elm code, you know. In fact, well, this is my blog post. Come here. Where you at, Elm code? Where I put it at? This is my domain. Come here. All right. So you take this right here. This type alias login function. And as I stated earlier, we when we're declaring our when we're declaring the abstraction or an interface for our functions, hence to support dependency injection, when we do this, we're declaring a type that will represent an interface to a function. In this case, I call this login function, but this login function is really an interface, right? And we're actually, instead of, how do I say this? Well, I'll just say it like this. We're providing the signature of the interface that we expect functions to comply with, okay? So any function that wants to implement this interface that we call login function, they must accept, or they must provide as their parameter a model. In this case, it's a model within our login module, okay? And so that model is actually, where you at? The model is actually this right here, okay? They have to provide as a parameter any function that wants to implement our interface called login function. They have to basically provide as a parameter this model right here. All right. In addition to that, where am I at? Oh, why did it leave the? In addition to that, where's my thing at? I was in domain, wasn't I? Yeah, there we go. So in addition to them having to, any function that wants to implement this login function interface, in addition to them having to provide a parameter that is of type login.model, they also need to return a result that is of the same type login.model. All right. So within functional programming, as I understand, this is healthy because this is helping me like solidify my understanding. So within functional programming, as I understand, in order, one technique, should I say, to implement or to support dependency injection is to basically provide an interface that functions can implement by establishing a type or declaring a type, and then providing the signature that all the functions need to have right? The parameters and the return type, right? And that's it right there. So I think that's pretty decent how I explained it. There's always room for improvement, but yeah, I think that should be understandable. This is different from object-oriented programming, the technique that they use, because as I said earlier, they tend to rely on um, parameters within the constructor of a class or using a glorified dictionary to inject their dependencies. Glorified dictionary is me making fun of an IOC container. All right, so what's next? Okay, well, over here, yeah. What's next is over here. Within the same module, which is our domain.core, all right, this is my module called domain.core. This is what most of the modules are going to depend on uh, for commonly used types, if I could say that. So after we declare our interface called login function, in which we basically identify the signature that all other functions need to have in order to implement this interface, we then provide a function that will actually leverage this interface. Okay, so we have a function called try log on or try login. This try login will have the following parameters. It's going to have the login function that we recently declared up here, and it's also going to take uh, a string and another string. The first string is going to represent the username, right? The other string is going to represent the password. Okay. So altogether, this try login function is going to take three parameters. It's going to take the interface to a function, or basically it's going to take an implementation of this interface up here called login function, which is nothing but expressing the signature of functions that are going to implement the interface. And it's going to take a username, it's going to take a password. And so the way that we actually execute this function is whatever function that a client passes in that implements this interface called login function, we're going to go ahead and we're going to, when they pass that in, we are going to attach or provide via partial application. I hope I'm saying this right. We're going to provide the username and the password. And there's another argument that is more of an implementation detail. False means, well, you don't have to worry about that. Don't worry about that. So this is what I have learned, or this is my current understanding, is when within functional programming to do dependency injection, you first declare a function type, not a function, but a function type, in which you express the signature of that type for the function. And then, so that's pretty much you basically declaring an interface for your function via the signature that your function is going to have, or that your functions have to implement in order to implement this interface. And then you can have an actual function that will take as a parameter that function type, along with any of the other parameters that that function can use, that function type will rely on. In this case, we have a function type called login function, and we give it a username and a password. This is, I don't know, that probably still sounds pretty cloudy, but check out my blog posts, and you can also look at the source code on GitHub, and also check out Scott Blashen's F# for Fun and Profit. because that's actually the material or documentation that I referenced. Even though it's F sharp, it's still functional programming, you know? And so it was very helpful in order for me to accomplish this. So I attempted to discuss how to declare an interface in which you basically identify the signature of the function or of the interface that your functions need to implement. And in addition to that, I also showed an example of how to leverage that interface by doing partial application, meaning that you can postpone the actual execution of that function by later on passing in arguments, right, until all the arguments or all the parameters of that function have been satisfied with corresponding arguments, and then that function will execute. That's the way I understand it. Now that I've discussed that, what else? All right. So within well, let me show you how it's used. That'll probably be better. All right. You see this right here? This try login latest. Well, this runtime dot try log on latest. Well, latest is basically this is going to be kind of complicated. All right. So latest is our actual model, right? So this latest is actually the result of us calling an update function within our login module that actually returns a model, okay? So if we go to our login module right here, and we look at the update function, which is right here, guess what it returns? A model, okay? That's all it does, right? And we see it over here. This is the model that gets returned, okay? Now, to take you back, that's the same model that we declared in our interface, okay? For our login function, which is our interface, we say it takes a model and it returns a model. Hence, the model is defined in our login module. All right, so let's go back. Let's go back. So we see here that we pass in the model to our update function along with a message. It's going to return a model as a result. We tag that model with the name latest, right? That's the name of the model. And then we call this runtime.try login latest. So what is runtime? You know, what does that mean? This try login looks familiar. What is this? All right, well, that's a good question. Let me scroll up. All right, so let me just hurry up and recap. This is an example of how we leverage the interface, or we leverage dependency injection, okay? But to add on to that, this runtime, what is that? Well, okay, so where is that at? Runtime. Where is that at? Hold up. Runtime is, where you define that? Okay. Okay, yeah. So runtime is basically a value in which we basically do pattern matching on another value called configuration, in which there could be, there's within this configuration that we're doing pattern matching on, we have two case values, their integration or their isolation, Well, what does that mean? What are we talking about? So you declare something called runtime, and it does pattern matching on configuration. Like what's configuration? All right. Well, okay. Well, let me tell you what configuration is. Configuration is basically a type that we have, and we it's a discriminated union in which it it has the following values or the following cases, or union cases: integration and isolation. Well, okay. Well, you said that configuration is a discriminated union in which the union cases are integration isolation. What does that mean? All right. Well, I'll tell you what it means. At least I'll try to. Integration and isolation is basically the different modes that your application can run in. Okay. So the way that I engineer my applications, especially for desktop and mobile, is I want to be able to. I'm yawning right now. Pardon me. I want to be able to basically troubleshoot my applications as quickly as possible based on some discovered anomaly. Okay. And so what helps me is to quickly identify if this anomaly that has been discovered stems from business logic or stems from integration logic. Business logic is basically the business rules that have been implemented that are within my domain, right? It's 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 the implementation of my model that does not care about a web server. It doesn't care about a database. It doesn't care about a user interface. It is the implementation of my domain logic, and that's it. It doesn't care about anything that the domain logic ultimately is going to interact with. My domain logic is a component within the overall system. Hence, integration means that this domain logic is actually going to rely on the outside world, meaning my domain logic is actually going to rely on external interfaces to do I/O. Okay, I/O being the user interface, putting things on the screen and accepting requests from the outside world, and then forwarding that request to my domain model. My domain model handles that request, executes a function, returns a result. That result pretty much gets rendered on that UI, right? If we talk about a web server, web services, then it's pretty much the same pattern. Uh, we need we need to get some data. So ultimately we can render it on the screen. Well, if we're in integration, in order for us to get data, in this case, we're going to rely on web services. Web services relies on some endpoint based on some arguments. Say, hey, give me something. Here's some arguments that you can use in order to give me what I want. The web server takes those arguments, computes something, and returns back some value, right? That value can be a collection of values. The value can be some instance, whatever it is. Basically, integration means relying on that external interfaces in order to accomplish a task. That's integration. Isolation is my application can run completely isolated. It is self-contained. It doesn't need any external interface in order for it to operate. It is good, all right, meaning that it doesn't need to rely on web services. It is self-contained. It can do it on its own. That's what isolation means. This is the way I build my applications, right? Because the majority of the time that we spend building systems or building applications, we spend debugging, right? So why not put in some infrastructure to reduce the time that's required to debug or to troubleshoot? Why not build that in? It's part of the architecture. Anyway, so that's what configuration is. I also have a type called dependencies, hence dependency injection, right? Short for, or an alias to glorify a dictionary within object-oriented programming. But in here, we don't have a dictionary, right? We don't use an ILC container. So this dependencies is actually a record type that right now just has one property, and it is the login function. Does that look familiar? This login function. This login is our login module. The login function is the type that we declared in our login module. Yo. So that has to sound familiar, right? So where is that type at? Hold on, that's right. No. I said that wrong. Forgive me. That login function. Oh, I might have said that right. Where is that at? No. Am I in login? I'm in login. Login is controls.login as login. All right, so we're good. And then if I scroll down, it's called login function. So I might have to delete this video because where's login function at? No, where's login function at? Hold up. What am I doing? Login. All right, just try login is the name of our property and is of type login.login function. And this isn't Visual Studio, so I can't just do F12. How do I view the? And I don't see login function in my login module. All right. Let me repeat. Login module. It's this right here, controls.login. If I go to, and if I go to controls.login, then I expect to see something called login function. I don't see it in here. This doesn't make sense to me. Yo, I'm gonna have to delete this video. Hold on. No results. What am I doing wrong? Controls.login. Uh, uh, this isn't right. I don't understand how this works. Type alias dependencies is our type. Try-login is one of our properties in which it is of type login.login function. And I don't see you in it. Okay, so let me do Control F and type alias login function is down here. Oh, la. Okay. That login function type is actually defined in our core.elm. And we import our controls.login as login. Okay. And we expose the login function in here. All right. This is kind of confusing. So, all right. So I'm still learning this. So just because we said that, if I understand this right, just because I said that my login, I don't know, I would like to call this like a namespace. I don't know if that's fair to say in Elm or accurate to say in Elm, but even though I imported a controls.login and I gave it an alias called login, and then I said, hey, here's a property, its type is going to be login.login function. That login function did not belong or was not exposed in my controls.login, right? It was never exposed in here. However, it was exposed in a completely separate module, in which in that separate module, we actually imported the controls.login and we gave it the LES login. And we exposed the login function, which means that within that file that we are actually referencing the property of type login function, we have to import a domain.core up there, and that's the only reason why that would work. So we go up here, and where's our home.elm, and we do domain.core. All right, and we expose everything. All right, so that was me getting confused, but I just learned something. So, all right, that makes sense to me. If I return back to my regularly scheduled program, go back to home, that is where, go back, we have our dependencies type, which is of type record, and it is going to expose a property called try login. That try login is really an interface to the login function type, right? Well, it's an interface. This type is login function. All right, that's our dependencies. And so the way that we use that is I then declare, oh, this isn't really a value or a function because it doesn't take any parameters. It doesn't even take a unit. So I declare a value called runtime. Runtime is pretty much of runtime is of type dependencies, which we have up here, which means that runtime is a record. It's a value of type record that exposes a property called try login. Okay, and try login is of type. Well, try login is a property that implements this login function. So within this runtime, we, as I said earlier, we do pattern matching on configuration, which we expressed as, well, where's configuration at? Configuration, we declared as a value up here, and we automatically just said, hey, this is going to be isolation. So depending on the mode, remember, isolation is a mode, integration is a mode. This is how we're running our, in this case, I don't want to say web application, but this is how we're running our web page right here, which is the home page, home.elm. So let's scroll down. Our runtime value that we use later on within our code is doing pattern matching on our configuration. Our configuration is hard coded to be of type, what? It's isolation, right? Yeah, our configuration has been hard coded to be of type isolation. And so when we pattern match, ultimately it's going to return this dependencies. Well, it's going to initialize our dependencies model, and it is going to provide the function of called try login that is defined, pardon me, in our test API. So I don't know, people are like, test API? Oh, I'm so confused. Scott, you butchered this. I know I did. I know I did. But this is actually me learning and me trying to solidify my understanding. So it's still possible I'll delete this video and start over. But anyway, so we know that our runtime is basically going to do a pattern match, and it's going to return, and it's going to basically say, hey, this configuration, it matches with isolation. And so we're going to return a model, because remember, dependencies is a model. Whenever you see dependencies, whenever you see a type alias and then some name, that alias enables you, as I understand, to initialize. This is kind of like a constructor where you could provide the name of the type, and then you can just start initializing the values, right? In this case, there's only one property in here. That property is called try login of type login function. That login function is our interface. And so we provide the implementation for our interface. That's it. So, okay, you said you provide an implementation for an interface for our dependencies record instance. Okay, so what is that? What is test API? Such that it has this try login function. All right, well, let's go there. I wish this was Visual Studio. This is Visual Studio Code, so I can't hit F12 and I can't right click and say go to definition, which is really annoying. But so this this test API is defined right here, and so we have our module test API, right? And oh, lo and behold, here's the try login function. And just like I expressed earlier within, where am I at? Core.elm. As I expressed earlier, this login function is, or this type login function is our interface. Pardon me. It takes a model as an argument, and it returns a model. And so when we look at our test API, what the freak? How did I lose the file already? When we look at our test API, which is over here, we see try login, and it takes again a model, and it returns an argument. Right? It's the same signature. That's the way that this dependency injection works within FP. Is our functions that implement that interface that we defined has to have the same signature. So our try login has an argument called credentials, which is nothing but, or our credentials is of type model, or our login.model, and it has its own little implementation, and it returns a login.model instance. I don't know if I could say instance with it for a record, but it returns a login.model value. How about that? And that's pretty much it. I know I kind of butchered this, but yeah, that is it. The source code is on GitHub. You could reference a blog post as well. And if we revisit this home.elm, then maybe this will make a little bit more sense. So within here, we return a model within our update function of our home page, right? This is the update function. It returns a model. And so when it does pattern matching and it hits this on login message that it matches with, then one of the cases is we do another pattern match on a sub message. These are messages that are defined within our login module. And we basically say, hey, runtime, or we call it runtime record, or we call it runtime value. Where is that at? Right here, which is of the dependencies record. And we say, if I scroll back down here, we say try login, all right? And then we pass in the model that's called latest. So this runtime.try login is right here, right? And that's how it works. This try login is a property that is of a type interface. And remember that we did some pattern matching, and we basically how do I say this? We're actually using the test API.try login as the implementation behind that interface. And so this is what gets called because we're doing isolation mode, which we defined as our configuration up here that's hard coded. Okay. Yeah, I feel really sorry for you because I don't think I did the best job trying to articulate how this dependency injection is done in functional programming. But yeah, it's more for me than it is for you. Please believe that. All right, so let me stop sharing my screen. And that's pretty much it. So what did I cover? I covered configuring your, in this case, it was a web page, but normally it's a web application to run in one of two different modes. Isolation mode, which it doesn't rely on web services in order for it to operate successfully. In this case, it relied on a test API library that will provide the data for it. You know, it's self-contained. So that's isolation mode, or we have integration mode in which it will rely on external interfaces, hence web services. So I discussed how to set that type of configuration up. In addition to that, I attempted to provide a dissertation on how within functional programming, a technique that I'm aware of is when you want to do dependency injection, you declare a function type, okay? And when you declare a function type, you're basically expressing the signature that all functions need to have in order for them to implement that type of function, right? Or that function interface. So I talked about that, and then I showed a test API module that actually has a function called try login that has the same signature as our function interface that was previously defined. And this is how we are able to do dependency injection. And that's it. So I think I think between functional programming and dependency injection, the combination of them both, I know I could do a better job articulating, but I mean, this is my first stab at it. And I think I did probably a better job on my blog post explaining it. So I'm going to take this video, I'm going to embed it into that blog post. That blog post I showed earlier, right? And yeah, that's it. So I'm Scott Nimrod. I do native application development, desktop, mobile. I like using Microsoft tools, Xamarin, WPF, and I know some F Sharp. And now trying to enter this web space because I've been putting it off because web development sucks. But this tool called Elm, or this programming language called Elm, is something that I decided to investigate because it might be just what I need to enter this web space to start helping clients, I don't know, with web applications that they need to make a lot of money or save a lot of money. So that's it. I'm Scott Nimrod. Adios, te veo a ratito. I'm available for hire, and I'm out. Adios.